Hi everyone, this is Babaiah, Assistant Professor of EC Department, MLR Hyderabad. Today I am going to explain about Introduction to Control Systems. In this control system, we have a 5 units are available. Now we are going to discuss the overview of this control system. Let us move to overview. Here observe system, control system, and importance of the control systems. Here what is mean by system? Here observe the next slide. Whenever the number of elements or components are connected in a sequence to perform a specific function, the group thus is formed is called a system. In a system, when the output quantity is controlled by an varying the input quantity is called a control system. The system. Here now system, what is meant by system? Whenever a number of elements or components connected in a sequence to form a specific function, the group is formed. That group is nothing but the system. In that system, the output quantity is varying with the input quantity is called the control system. We have a more number of control systems are there. Room heater, refrigerator, and traffic light signals. That is the best example for the control system, traffic light signal, and washing machine. All these are the best examples of the control system. Also switch, also just switch, and electrical lift. All these are comes under the control system examples. Here observe what is the importance of the control system, or why we are going to study the control system. Now we are going to observe the next year. Now why we are going to study control system, or what is the importance of the control system? Here observe, basically we are going to use these four parameters to design the any type of control system. By using these are the four major reasons or else four major parameters. Coming to the first one is the power amplification. This is the power amplification, and next one is the remote control, and the third one is the convenience of input form, and fourth one is the compensation for disturbances. Coming to the power amplification, here observe, coming to the power amplification means the low power or less power, low power converted into the higher power. So in that case, we are going to use the control system here. But the best example for power amplification here, radar antenna. I consider as one radar antenna. Here, radar antenna. Here, when I am going to rotate my radar antenna I consider as the big size of the radar antenna that I am going to rotate by using the knob. By using the knob, I require only less amount of power. But here the big amount of radar I want to move physically, it will take or it consider as the more power required. So in that case, we are going to use the power amplification. That is the major parameter for design of the any control system. And next the here radar antenna moving by using the knob, that internally having the some motors. The motors are called as the control system, right? Motors are called as control systems. That motors are amplifies the power from low power to the high power. Then the antenna or radar antenna will be going to move or rotated. What we required position, that can be that position the radar can be moving. And here coming to the remote control. Remote control is the second parameter. Remote control, the best example for remote control, robot. I consider as one robot arm. Robot arm can be used to pick up or place tiles from the any dangerous situations or dangerous area or any dangerous situations from that we consider as remote control. Robot can be used to pick up the tails from the any effective areas or effective environments also. We say that effective environment areas, by using the robot we can pick up or place the any particles in that area. By that we are going to use the robot by using remote control. And convenience of input form. Convenience of input form. Here observe, suppose I am in a air conditioner room. Now I want to decrease my room temperature. For that I am going to use the remote, AC remote. Now I want to the particular temperature, so that's why I am going to use the remote control. I want to decrease my room temperature to maintain the our convenience in the convenience form. That is the convenience of input form by using the remote control, right? That is the best example for convenience of input form, changing the convenience of input form, decreasing the temperature. And compensation for disturbances. Here this is the very important compensation for disturbances for any control system. For example, I want some amount of output I required, but the control system is getting the output, it has some errors are there. For every control system or else control system is rectify or automatically rectify those errors are occurred, that errors are going to rectify itself only. The control systems are rectified the errors itself only. That is the compensation for disturbances. So that's why we are going to design the control system by consider as all these are the parameters. Moving from the rest position to some speed 100 kilometers per hour or else 80 kilometers per hour. That is one of the example for the control system. For example, car. Car is a car having any elements internally. The car is nothing but the control system in that situation, and the speed of the car is 110 kilometers per hour. For example, 100 kilometers per hour. That is our desired output, right? Next, coming to the second example, I consider as one lift. One electrical lift moving upwards. Lift is the control system. What we required the floor of the building. Choose the floor of the building. That is our desired output, right? And next, coming to the third one is just an air conditioner room is maintaining the temperature of the room. Air conditioner is the control system. Maintain the temperature of the room is the our desired output. All these are the just two basic examples of the control system. This is the importance of the control system. And for this control system, we are going to learn coming classes the introduction to control system and time domain, time specification or time response analysis. In that we are going to learn the time response analysis or time domain specifications. And next, third is the frequency domain specification, and fourth one is the we are going to learn the state space analysis also. We are going to learn. All these are going to learn in future. Some basic type of systems are available. Just you know all these already, but I will explain all these. Okay, these are the importance of control systems and why we are going to study the control system by using these are the parameters, right? Okay, coming to the types of systems. Here observe linear systems and non-linear systems, time variant systems, time invariant systems, linear time variant systems, and linear time invariant system. All these are the basic types of systems we have. Here coming to the linear systems. Linear, what is mean by linear systems or linearity? The overall response of the system is equals to the individual response of this system is known as the linear systems. And linearity, if the linear systems or else if any system, whenever the system is obeys the linearity or homogeneity or superposition, that type of systems are called as the linear systems. Here I consider one system. For that I am going to give the individual responses. After I will get the total responses. The individual responses will be is equals to the total response. If it is equal, then the system is linear system. Now I am going to consider here, just observe, I am going to give one input signal x1 of t, apply to the some system a1, and I am from that I am going to get the responses y1 of t. Here y1 of t equals to a1 and x1 of t. Next I am going to apply the second input signal x2 of 2 given to one signal a2, and this is the response y2 of t. The output of second response is y2 of t equals to a2 and x2, a2 and x2 of t, a2 and x2 of t. These two are the individual responses. Let us consider as one system. Here observe, this is my input signal x1 of t, and here the output is x1 of t, x1 of t into a1. This will be is given to one error detector plus, and one more is second input x2 of t, this is a2, x2 of t into a2. The final output is y3 of t. The y3 of t is equals to x1 of t a1 plus x2 of t a2, x2 of t a2. Here observe, y3 of t equals to, this one is nothing but the y1 of t, this is nothing but y2 of t. These two are the individual responses. Here observe, the total response of the system y3 of t is equals to the individual responses. This is nothing but the linearity. This is nothing but linearity. Whenever the system's overall response is equals to the individual responses, the type of systems are called as the linear systems. The linear systems are must be follow the or obey the linearity, homogeneity and superposition. Okay, the type of systems are called as the linear systems. And next coming to the non-linear systems. Non-linear system, whenever the system not obey the or not follow the linearity or homogeneity, the type of systems are called as the non-linear systems. Next coming to the time variant system. Time variant system, if the system output is varying with the time, If any control system output is varying with the time, the type of systems are called as the time variant systems. Next, coming to the time invariant systems. Time invariant systems means whenever the system output is not varying with the time. Whenever the system output is not varying with the time is known as the time invariant system. Next, coming to the linear time variant system. If the system is both linearity and time variant. The type of systems are called as the linear time variant systems. Coming to linear time invariant systems. If the system is linear and time invariant system. If the system both linearity and time invariant, the type of systems are called as the linear time invariant systems. All these are the basic types of systems. Here, some of the examples I am going to give for the control system. For example, a refrigerator is there. A refrigerator and air conditioner, washing machine, traffic lights. Best example is the uh, traffic light signals. Traffic light signals here, just observe, just assume here, assume one traffic signal. Just assume, imagine the traffic signal. For here, a sequence of input is given, or a sequence of input signal is applied to the any junction of the signals. For based on the time slots, the traffic light signals, one out of the uh, junction, one is on position, the remaining three are the off position based on the time slots. It relieves the in any particular junction, the traffic is released based on the time slots. It will on means green color, so it will activated. So in that way, that traffic is clear or relieve the vehicles at a particular junction of the signal, right? That is the basic example of the traffic light signals. And also to teacher student learning also, or student teacher learning process also, one of the best example of the system, right? Best example of the control systems. Now coming to classes, I'm going to explain detail. Okay, this is the today's session and brief overview of the introduction to control system. What we learned for first session, or for this session, just what is mean by system, what is mean by the control system, why we are going to study the control systems. Based on the four parameters, we are going to design the control system, and also what are the basic type of systems are available that we are seeing. All these are just to be learned for from this today session. Thank you.